All right, welcome back for another deep dive.
Thanks for having me.
Today we're going to be looking at something I bet most people don't even think about.
Right.
But it's something we all rely on every single day.
Absolutely.
We're talking about how our electronics are protected from something called electromagnetic interference, or, EMI.
Yeah, that's it. EMI.
And to help us understand how it all works, we're going to be diving into some technical documents
Sound good?
for the CDG 7000 Conducted Disturbances Test System.
Okay.
And we've got an expert here to break it all down for us.
Happy to be here.
What's fascinating about this is most of us, we don't even realize all the invisible forces out there that could, totally mess with our phones.
Uh-huh.
Or even things like medical devices.
Oh, yeah, that's true.
So to kick things off, maybe you could tell us, what exactly does this CDG 7000 thing do?
All right, so think of it kind of like a stress test,
Okay.
for all your electronics. The CDG 7000, it simulates the kinds of electrical disturbances that can be caused by things like radio waves.
Right.
Or magnetic fields.
Mm-hmm.
It's basically, helping manufacturers make sure that your phone, for instance, isn't going to just suddenly die just because you walked past a radio tower or something.
That makes sense.
Or that your pacemaker won't go haywire near a microwave oven.
Oh, wow. Okay. That's a pretty powerful image.
Right.
So how does the system actually work? I mean, from what I've seen so far, it seems a lot more precise than just blasting a device with a bunch of random electromagnetic waves.
You're right. It really is incredibly precise.
Okay.
The CDG 7000, it uses a technique called direct sine wave injection.
Okay.
Instead of using those, big bulky antennas in shielded rooms and all that, it injects specific electrical signals called sine waves directly into the power lines of a device.
Interesting.
Or the signal lines.
So it's it's kind of like targeting the exact pathways, I guess.
Yes.
Where interference could cause a problem.
Exactly.
Interesting.
And what's really cool is that this allows you to test the device in its natural environment as part of a larger system. Which gives you a much more realistic picture of how it will actually perform out in the real world.
Right. Yeah, that makes a lot of sense. And speaking of being out in the real world, let's talk about the different models of this CDG 7000.
Okay.
The document mentions a couple of different ones, each with a different frequency range and power output and stuff like that. What's the significance of those differences?
Well, it's kind of like matching the right tool to the job, right? So different devices, they're susceptible to interference at different frequencies and intensities.
Okay.
So, for example, a cell phone that operates at much higher frequencies than, say, a washing machine.
Right.
So the model, of the CDG 7000 that you would use would depend on what specific device you're testing.
Right.
And the kind of environment it's going to be used in.
So if I'm testing a device that uses Bluetooth, for example, I would need a model that can handle those specific frequencies.
Precisely.
Okay.
And the power output is really important too.
Okay.
Because a device that operates in a high interference environment, like a factory floor or something, would need to be tested.
Okay.
With a higher power output.
Right.
To make sure it can handle those conditions.
Interesting.
Yeah.
So let's get into some specifics here.
Right.
The document lists 3 different models.
Okay.
The CDG 7025.
Okay.
The 7075 and the 7075-10. Can you kind of walk us through how they differ?
Sure. So the CDG 7025, it has a frequency range up to 250 megahertz.
What?
And an amplifier power of 25 watts.
Okay.
This is often used for testing things like automotive electronics.
Right.
Or industrial control systems.
Okay.
Which typically don't operate at very high frequencies.
Right.
The 7075, on the other hand, it goes up to 400 megahertz.
Yeah.
And has a more powerful 75-watt amplifier.
Wow.
That one is better suited for testing, things like telecommunications equipment.
Okay.
Or wireless devices.
Right.
Things that operate at those higher frequencies.
Got it. And what about that 7075-10 model?
Okay, so the 7075-10.
Yeah.
That's an interesting one.
Okay.
Because it actually It has a lower frequency range.
Okay.
So starting at 10 kilohertz.
Right.
And going up to 250 megahertz. But it still has that powerful 75-watt amplifier.
Okay.
So this model is often used for testing large industrial equipment.
Right.
Or power systems.
Okay.
Things that operate at those lower frequencies.
Got it.
But they still need a higher power output for testing.
So it's all about matching the right tool for the job, basically.
Exactly.
Depending on the frequencies and the power levels involved.
That's it.
Okay.
And that's why the CDG 7000 is designed with flexibility in mind.
Speaking of flexibility, this technical document that we have here,
Yeah.
it mentions a bunch of key facts about the system.
Huh?
One that caught my eye was that it has application software for reporting and monitoring.
Yeah.
That seems pretty important for a system like this, right?
Absolutely, yeah.
Yeah.
It's not just about running the tests.
Right.
It's about understanding the results.
Right. Okay.
The software, it allows users to monitor the device's performance in real time during testing.
Okay.
So they can see exactly how it's reacting to those induced disturbances.
Okay.
And then they can generate detailed reports.
Got it.
To document and analyze those results.
Okay.
It's an essential tool
Perfect.
for making sure those electronics are really up to snuff.
Now, I gotta admit, when I first skimmed through these key facts, my eyes kind of glazed over when I saw temperature measuring input.
Oh yeah.
What's so important about measuring temperature during testing?
That's a great question.
Okay.
And it highlights an important part of all this testing.
Okay.
And that is safety.
Ah, okay.
Right.
Great. Yeah.
Especially when you're dealing with these higher power signals, you need to make sure that that nothing's overheating.
Right. Right.
So the temperature measuring input ensures that the testing environment itself stays safe.
Okay.
And within acceptable parameters.
Right.
Both for the equipment
Mm-hmm.
and the people who are operating it.
Yeah, that makes sense. I never really thought about the safety implications.
Yeah.
Of testing like this, but of course that's got to be like a top priority.
Absolutely. Yeah, and the CDG 7000 was definitely designed with safety in mind.
All right, so we've got a good understanding now of the basic idea behind the CDG 7000.
Okay.
How it works and some of the key features that make it such a powerful tool.
Uh-huh.
But before we move on to some of the more the more technical aspects,
Okay.
I want to step back for a minute and ask, why should our listeners even care about this?
Right.
What's the real world impact
Yeah.
of all this electromagnetic compatibility testing?
That's a great point.
Yeah.
It's easy to kind of get caught up
Right.
in all the technical details.
Right.
But ultimately this all comes down to making sure that the electronics we rely on every day are safe.
Right.
And reliable.
Right.
Just think about it. Your phone, your car, your microwave oven,
Yeah.
medical devices.
Uh-huh.
I mean, almost everything we use these days relies on electronics.
Right.
And if those electronics malfunction
Yeah.
because of electromagnetic interference,
Right.
well, the consequences could be anything from, just a minor inconvenience
Right.
to a serious safety hazard.
Wow. Yeah, you're right. So in a way, this technology is kind of it's kind of invisible, but totally essential to our modern world.
Exactly.
Yeah.
It's working behind the scenes.
Right.
To make sure that that our increasingly interconnected world functions smoothly and safely,
Mm-hmm.
and that's why understanding the basics
Okay.
of electromagnetic compatibility,
Right.
and the role of systems like the CDG 7000
Right.
it's so important.
Okay.
Yeah.
So the next time your phone drops a call,
Yeah.
or your laptop crashes or something,
Uh-huh.
you might just have a electromagnetic interference to blame.
You just might,
Oh wow.
but hopefully,
Yeah.
thanks to rigorous testing with systems like the CDG 7000,
Right.
those occurrences are few and far between.
All right. Well, I think we've got a good foundation here.
Okay.
Now let's dive into this world of accessories.
Sounds good.
This document, it lists a whole bunch of stuff: coupling networks,
Uh-huh.
EM coupling clamps, BCI probes. It's like,
Yeah, it's a lot.
It's almost like a toolbox for electromagnetic interference.
It kind of is, yeah.
Where do we even begin with all this stuff?
Yeah, it really is kind of like a toolbox, isn't it?
Right.
Each of these accessories
Yeah.
plays a specific role
Okay.
in helping the CDG 7000 do its job.
Oh.
And, depending on what kind of device
Right.
you're testing and what you need to learn about it.
Okay, that makes sense. So let's start with the coupling networks.
All right.
I see a whole bunch of them listed here with these kind of crazy names like CDN M1
Right.
and CDN M4 326 3100 HV.
Yeah.
What's the deal with all these different types?
Well, remember how we talked about how the CDG 7000 injects those sine waves
Right.
directly into the device's lines?
Yeah.
Well, the coupling network, that's what actually makes that connection happen.
Okay.
It acts as a bridge, basically, between the CDG 7000 and the device under test. Making sure that the interference signals are applied accurately and consistently.
So different coupling networks are needed for different types of connections.
Exactly.
Okay.
You wouldn't use the same coupling network to test a device with an Ethernet port as you would for a device with a USB connection.
Right. Okay, that makes sense. And I see some of these coupling networks have these pretty complicated names.
Yeah, they do.
Like that CDN M4 326 3100-HV.
Yeah.
What do all those numbers and letters mean?
So those numbers and letters, they refer to the specific electrical characteristics of the coupling network. Things like impedance,
right,
and voltage handling capability.
Okay.
It can get pretty technical,
right,
but the main takeaway is that each coupling network is designed for a specific type of connection,
right,
and signal. So making sure that the interference is applied in this controlled and accurate manner.
Okay, so it's all about again, it's like having the right tool for the job depending on the specific device you're testing.
Exactly, yeah.
Okay.
Now, let's move on to those EM coupling clamps you mentioned.
Okay.
Remember we talked about how sometimes interference can be introduced through a device's wiring,
right?
Not just through its power lines or signal lines.
Right. So the EM coupling clamps are used to kind of simulate that kind of interference.
Exactly.
Yeah, sure.
So imagine you have a device with with a long cable connected to it.
Right.
The EM coupling clamp.
Okay.
That would be attached to that cable.
Okay.
To induce the interference.
Right.
Allowing you to see how the device reacts to that kind of real world scenario.
So it's like simulating the interference a device might pick up from like a nearby power cable or something like that.
That's a great way to think about it. Yeah.
Okay.
And just like the coupling networks.
Okay.
There are different sizes of EM coupling clamps.
Okay.
Designed for different cable diameters.
Okay, so if I'm testing a device with a really thick cable, I'd need a bigger clamp, I guess.
Exactly.
Makes sense. What about those decoupling clamps? I saw those listed there.
Oh.
They sound kind of like the opposite of the EM coupling clamp.
So you're on the right track.
Okay.
Decoupling clamps.
Okay.
They're used to minimize any unintended interference.
Okay.
During testing.
Okay.
So while the EM coupling clamp is intentionally introducing interference, the decoupling clamp is working to block out any stray interference that could mess up the test results.
So it's about creating like this controlled environment where you can isolate the specific type of interference you're trying to test.
Exactly. Yeah.
Okay.
It's think of it like this, like you're trying to listen to a specific conversation.
Okay.
In a noisy room.
Yeah.
The decoupling clamp, it's like putting on noise canceling headphones.
Right.
So you can focus on the conversation you want to hear.
That's a great analogy.
Right.
So the EM coupling clamp is the person speaking, and the decoupling clamp is the noise canceling headphones.
You got it.
All right, now let's talk about those BCI probes.
Okay.
Or bulk current injection probes.
Okay.
This is where things get really interesting.
Yeah, this is a fun one.
Okay.
Yeah.
We touched on this concept briefly before, but I'm still a little fuzzy on what bulk current actually means.
Okay.
Can you kind of break it down for us?
Sure, sure. So, think of bulk current as, as the main highway
Okay.
of electrical current
Right.
flowing through a device.
Okay.
It's, it's like a multi-lane freeway carrying tons of traffic.
Right.
And just like, a traffic jam
Yeah.
can snarl up, the whole freeway.
Right.
Interference that's introduced into the bulk current path
Okay.
can affect the entire device.
So it's testing the device's ability to handle interference, I guess, at its core.
Exactly, yeah.
Okay.
Rather than just on specific signal lines.
Okay, and why is that important?
Well, because sometimes interference doesn't just affect a single wire or circuit.
Right.
It can impact the overall flow
Right.
of current
Okay.
within the device, causing all sorts of unexpected problems.
Wow, that's pretty scary when you think about it.
Yeah.
It really makes you realize, just how vulnerable our electronics can be.
Yeah.
To these invisible forces.
That's true, but that's why systems like the CDG 7000 and all these accessories
Right.
are so important.
Right.
They allow us to understand these vulnerabilities and design electronics that can withstand the rigors of the real world.
All right, so we've got the coupling networks.
Okay.
That make the connection.
Yeah.
We've got the EM coupling clamps that introduce this controlled interference.
Right.
We've got the decoupling clamps that block out unwanted interference.
Yeah.
And the BCI probes that test the device's core resilience, I guess.
Exactly.
It's a pretty impressive arsenal.
Yeah, it is.
But I'm noticing that this document also mentions a lot of different calibration accessories.
Right.
Why is calibration so important in this context?
That's a crucial question. Calibration is all about making sure that the CDG 7000 is delivering the exact level of interference that's intended.
Okay.
It's like making sure that your measuring tape is accurate before you cut a piece of wood.
Right.
If the CDG 7000 isn't calibrated properly, well, the test results, they're not going to be reliable.
So it's about eliminating any variables.
Yes.
That could skew the results.
Exactly.
Okay.
And the calibration process that involves comparing a CDG 7000's output to a known reference standard.
Okay.
And making adjustments to make sure that everything is aligned.
And I see that the CDG 7000 it comes with a whole set of accessories.
It does, yeah.
Specifically for calibration. Can you kind of walk us through what those are and how they're used?
Sure. So the calibration accessories, they include things like attenuators, terminations, and special cables and connectors.
Okay.
So attenuators, those are used to reduce the signal strength in a controlled way.
Right.
And terminations.
Okay.
They absorb signals.
Okay.
To prevent reflections.
Right.
That could interfere with the calibration process.
So it's like fine-tuning the system to make sure it's operating at peak precision.
Exactly.
Okay.
And the specific calibration setup.
Yeah.
That'll depend on the type of testing being done.
Right.
And the accessories being used.
Okay. So it's a pretty complex process.
It can be. Yeah.
But it's essential for ensuring the accuracy and reliability of the test results.
Okay. Calibration is the foundation of good testing.
Right.
Without it, you're basically flying blind.
Well, I think we've done a pretty good job unpacking this toolbox of accessories.
I think so too, yeah.
From coupling networks to BCI probes and calibration tools.
Yeah.
It's clear that the CDG 7000, it's designed to be incredibly versatile.
Yeah, for sure.
And adaptable to a wide range of testing needs.
I agree, yeah. And it's that versatility that makes it such a valuable tool for ensuring the reliability of the electronics we depend on every day.
All right, we've covered a lot of ground here.
Yeah.
Now, before we wrap up,
Okay.
I want to shift gears a bit.
All right.
And talk about what's actually included.
Okay.
When you actually buy CDG 7000.
Okay, yeah.
This included in scope of delivery section of this document here. It reads like a shopping list. I mean, it really does. It's got everything from the essential power and USB cables to more specialized stuff like BNC connectors and SMA fixed cables.
Yeah, it seems like they've thought of everything you need to get up and running right away.
Right.
Those SMA cables, for instance,
Yeah.
those are essential for connecting the CDG 7000 to those coupling networks. And clamps and probes we were talking about earlier.
Yeah.
SMA connectors, those are commonly used in radio frequency applications.
Okay.
Because they provide a really secure and reliable connection.
Okay.
Minimizing signal loss and all that.
So it's all about maintaining the integrity of the signal, I guess.
Exactly.
Throughout the whole testing process.
That's right.
Okay. And I see they've also included some socket strips.
Yeah.
What are those for?
Those are probably for connecting the device under test and any additional equipment you might need.
Okay, that makes sense. It's like they're providing the foundation for your testing setup.
Exactly.
But I gotta admit, one thing on this list kind of threw me for a loop.
Oh, what's that?
It says it comes with a USB dongle.
Okay.
For the Halia dongle.
Right.
I mean, in this day and age, a USB dongle.
I know it does seem a little old school, doesn't it?
Yeah.
But when you're dealing with specialized equipment like this,
right?
Especially when it involves sensitive testing data.
Okay.
Sometimes a physical dongle.
Yeah.
That provides an extra layer of security and control.
Okay, so it's like a little security guard for your testing data.
You could say that.
And speaking of security, they've also included a user manual.
Oh, of course.
Now, I know user manuals aren't always the most exciting reads.
Right.
But they are crucial for understanding, all the ins and outs of a complex system like this.
Absolutely.
Right.
A good user manual that'll walk you through the setup process.
Yeah.
Explain all the different functions and features of the CDG 7000. And even provide some troubleshooting tips.
Right.
If you run into any problems, it's like it's like having a personal guide to help you navigate this whole world of electromagnetic compatibility testing.
And it looks like they've even included a USB stick.
Oh, nice.
Loaded with even more goodies. A calibration certificate, another copy of the user manual, and the Helia software itself.
Talk about convenience.
Yeah.
They really went above and beyond to provide, everything you need in one place.
Right.
That calibration certificate, that's particularly important.
Okay.
Because, it proves that the CDG 7000 has been calibrated to meet those specific standards, ensuring the accuracy of your test results.
So it's like a stamp of approval, I guess.
Exactly.
Verifying that your testing equipment is up to snuff.
That's a great way to put it.
And we can't forget about those RF cables either.
Oh yeah, those are important.
Those are the unsung heroes.
Right.
The whole system, I guess, right?
Yeah.
Carrying, those crucial RF signals between the CDG 7000 and the various components involved in testing.
Yeah.
The fact that they include 4 different types of RF cables.
Oh.
BNC to N to N, BNC to TNC, and a special N to angled BNC for the 75-watt version.
Wow.
That shows just how much thought they put into ensuring compatibility with a wide range of equipment.
Exactly. They really have thought of everything.
It's like they anticipated every every possible connection you might need.
Oh,
I mean,
yeah.
they've really covered all the bases here.
They really have, and I think that that just shows their commitment,
Yeah.
to making the CDG 7000 a truly comprehensive
Right.
and user-friendly
Right.
testing system.
Well, I think it's safe to say that we have thoroughly explored the CDG 7000 Conducted Disturbances Test System.
I think so, yeah.
We've gone from the basics of electromagnetic compatibility
Right.
to the intricacies of coupling networks
Yeah.
and calibration procedures.
Yeah.
And we even unpacked the contents of the box.
We did it all.
It's been quite a journey.
It really has, and I hope our listeners have
Yeah.
gained a newfound appreciation for this invisible world of electromagnetic interference and the technology that helps us keep our electronics running smoothly.
Absolutely. So the next time you're you're using your phone or driving your car,
Yeah.
or even just turning on your microwave,
Right.
take a moment to think about all the behind the scenes work that goes into ensuring those devices can handle those invisible forces all around us.
That's right. Yeah.
Right.
And remember, it's thanks to the ingenuity
Yeah.
and dedication of engineers and scientists
Yeah.
and systems like the CDG 7000
Yeah.
that we can
Yeah.
enjoy a world
Yeah.
where our electronics are reliable and safe
Right.
and for the most part interference free.
Well said. And on that note, we'll wrap up this deep dive.
Sounds good.
Thanks for joining us.
It's been a pleasure.
Until next time, stay curious.